Hey everybody, it's good to have y'all back once again as we continue on talking about solving equations. Last time we talked about transposing as a very powerful tool to help us solve equations. Now we're going to move on into something called the multiplication principle. So we're at 9.6 part 2, using the multiplication principle to help us solve equations. Let's start off by giving you an example of the multiplication principle. Let's say we had something like 6x equals 18. Okay, 6x equals 18. Now, you remember from our conversation on algebraic terms that 6x means the coefficient 6 times the variable x, or 6 times x. 6 times x. And so what we're trying to do here, guys, is we're actually trying to clear this coefficient off this variable. We would like to get the x by itself. So in order to do that, what we do is we use the multiplication principle. Which simply says we can undo that multiplication with division. So what we'll do is we'll take the 6x and we'll divide that term by 6. We'll divide the term 6x by 6. And then we'll come over here with the 18, and if we divide the left side of the equal by 6, in order to keep the equation balanced now, we need to divide the right side of the equation by 6. So whatever we divide on one side, we divide on the other side. This is how the multiplication principle works. Now when we divided this by 6, we were able to cancel that 6 out, and it left us with an x. And of course we worked this side out over here, and that gets us a 3. That gets us a 3. So the solution to our equation using the multiplication principle of 6x equals 18 is x equals 3. That's just a simple example of the multiplication principle. Let me see if I can give you maybe a thing of what the multiplication principle is used for and what it does. Okay, so we use the multiplication principle. We use a multiplication principle to clear coefficients of variables. If you refer to your last example that we just had put up on the board, we had put up 6x equals 18. Well, the 6x, the coefficient was the 6, and we wanted to clear the 6 off the x. So we used the multiplication principle to clear that coefficient 6 off that variable x. That's what we did. So this is one of the ways. We use the multiplication principle other ways too, but this is one of the ways that we use the multiplication principle. Now there's some aspects to this that we want to make sure that we talk about. Let's just say this. To clear whole number or decimal number coefficients. Let's see if we can spell coefficients. C-O-E-F-F-E-C-I-E-N-T-S. So to clear whole number or decimal number coefficients off a variable, we divide. And that's the example that we gave you. We had a whole number coefficient of 6. We divided it off the 6x. We divided it on the other side, and it was cleared off, and it gave us an answer. So we're going to use that multiplication principle to clear coefficients off the variables. We're talking about a whole number coefficient, okay, or a decimal number coefficient. We're going to divide to get that coefficient off. Let's do a couple more examples of that so you can kind of see it. Doesn't really matter if it's positive numbers or negative numbers. If we're talking about negative 5x equals 30. Negative 5x equals 30, okay? So right here, what we're going to do to get the x by itself, to clear the negative 5 coefficient off of there, we'll go negative 5x divided by negative 5. And then over here on this side, to balance the equation, important to keep the equation balanced, we'll take the 30 and divide that by negative 5. Now, the whole reason we divided by negative 5 is because we knew that that would cancel out the negative 5 or clear that coefficient off that variable. So this cancels out, leaving me x equals negative 6 for an answer. X equals negative 6 for an answer right there. Same thing is true if we're dealing with decimal coefficients. If I had, let's say I had 0.2x equals 0.12. 0.2x equals 0.12. Well, I would take the 0.2 coefficient and divide it off. And over here I take 0.12 divided by 0.2. That would cancel. Leave me x 0.12 divided by 0.2. I believe it's going to be 0.6. Yeah, 0.6. So 0.6 is my answer when I do that. So actually when I get it to this point, I could probably use my calculator and do 0.12 divided by 0.2. Okay, and you would see your answer is 0.6. So even if it's a decimal number coefficient, we can work it the same way. Now sometimes we have fraction coefficients. Aren't you excited? Fraction coefficients. Folks, if you're like most folks, when they hear the word fraction, see the word fraction, they begin to get a little bit bug-eyed. Fractions are not fun. Now, to clear fraction coefficients, we do something a little different. Okay, so let's talk about that and see how the multiplication principle works with fraction coefficients. Okay, so here's your step to clear fraction coefficients. To clear fraction coefficients, we multiply both sides of the equal or the equation by the reciprocal. Okay, of the fraction coefficient. All right, to clear fraction coefficients, now we're going to multiply both sides of our equal, or both sides of our equation, by the reciprocal of the fraction coefficient. This will make much more sense when you see an example. So let's take 5/9 x equals, let's say that equals 2/3. Okay, 5/9 x equals 2/3. Now remember, we're trying to get x by itself. That's really what we're trying to do. So what we're going to do, guys, is we're going to realize that fraction coefficient is 5/9. So what we're going to do is we're going to multiply both sides of this equation by 9/5. The reciprocal of 5/9 is 9/5. So we'll multiply this side of the equation, okay, by 9/5. And we'll come over here to this side of the equation and multiply it times 9/5 also. Okay, so we're going to multiply one. If we're going to multiply the left side by 9/5 in order to stay balanced, we'll multiply the right side by 9/5. Now the whole point in multiplying by 9/5 was to make 5/9 go away. Now watch what happens. The 9 cancels the 9, the 5 cancels the 5, and we're left with just a plain good old-fashioned x. So we have accomplished exactly what we wanted to accomplish. We've got that x sitting there by itself. Now we just got to work this side out. Multiplying fractions, remember, we can cross cancel and simplify. 3 goes into 3 one time, 3 goes into 9 3 times, so 2 times 3 is 6, 1 times 5 is 5. So the answer to this equation, 5/9 x equals 2/3, the solution is x equals 6/5. 6/5 is my solution. And I did that by multiplying by the reciprocal of 5/9. Now I did the reciprocal of 5/9 and not the reciprocal of 2/3. I wanted to do the reciprocal of the one that's the coefficient, the one that's on the x. That's the one I want to do the reciprocal of. That's the important one to try to clear out. Okay? Let's do another one of those so you can see a bit more about how that works. And this time we'll throw a negative in there. It won't really make a whole lot of difference, but let's do that. Negative 8/9 x equals, let's say, negative 8/9 x equals 4. Okay? Now, I want to get the negative 8/9 off the x. What do? You got it. Yeah. Multiply it by the reciprocal of negative 8/9. The reciprocal is going to be negative 9/8. So over here, times negative 9/8. Okay? Alright, so negative 9/8 reciprocal of that. Over here, let's take that 4 and give it a fraction look. Let's put it over 1 and multiply this side by negative 9/8 also. Alright, so we simply multiplied both sides of this equal by negative 9/8 because we were trying to get rid of the negative 8/9. That was our reasoning. So we cancel here, cancel here, cancel here, cancel here. Boom! Boom! Yes! X is by itself. That's what I'm talking about. We want that x by itself. Just like that. Ain't that good stuff, y'all? Alright, so let's go on. Let's do some canceling here. 4 into 4 goes 1 time, 4 into 8 goes 2 times. So what we'll end up with is a negative 9 over 2. A negative 9 over 2. Alright, so that's how we take care of a fraction coefficient. A fraction coefficient. One more piece to this that could be helpful to you. One more little way we can use this. Sometimes you'll have something like x over 8, let's say, equals, gosh, what do I want to do with that? X over 8 equals 5 over 9. X over 8 equals 5 over 9. You've got many ways you could deal with this, but remembering here, if what we want to do is get the x by itself, all right? One thing that we can do and keep this thing balanced is multiply both sides of this equation by 8 over 1. You see what will happen when I multiply by 8 over 1? Do you already see how those 8's are going to cancel each other? So if I come back over on this side and I do 5/9 times 8 over 1, you see, and I keep it balanced, I'm all good. So this can cancel this. I'll get x over 1, which by the way is simply x. X over 1 is x. Right here nothing cancels, so I'll get 40 over 9. If I want to change that into a mixed number, 9 into 40 goes 4 times. 4 times 9 is 36. With 4 left over, 4 and 4 9s. That would work also. All I did right there was 9 into 40. Just in case you weren't sure about that, it goes 4 times. That's 36. 4 left over, 4 over 9. Okay? And I didn't even have to do that piece right there. This is a simplified improper fraction. This is a simplified mixed number. Let me go back to what I was going after here. With this, guys, if we have something like this and we're trying to get the x by itself, using the multiplication principle, whatever I multiply on one side, multiply the other side by the same thing. Okay, whatever I divide on one side, divide the other side by the same thing. It was a really good idea here to multiply this side by 8 over 1. because that would cancel that 8 out. Or whatever that denominator was. That's what I'd multiply by. Do that here, balance it out by doing it here, do my math work, and I'm rolling. Good stuff, huh? Solve all kind of equations. I think that's enough on the multiplication principle for today. It's another powerful tool in solving equations. Next time we get together, we're going to talk about taking the 3 tools that we've learned, simplifying algebraic expressions, transposing, and now the multiplication principle. We're going to talk about those 3 things, those 3. We're going to put them all together into a nice plan that's going to solve just about any equation that you want to solve. I'll see y'all next time, and we will do it.